2 regulations because of this accident. So it was a flight from Dallas Fort Worth to Montreal Dorval International Airport. The DC-9 was half full of passengers, just 41 passengers. You should be, are you familiar with the Swiss cheese model? Good, where if something happens and maybe something else happens, holes line up, then you have a really bad day. So a lot of stuff going on in this accident. But in the cockpit, some circuit breakers tripped. Unfortunately, this had become a normal occurrence, so the captain tried to reset them, but that didn't work. But he's like, it's been happening, nothing unusual. Meanwhile, in the rear lavatory, passengers began to smell smoke. Passengers weren't in the lavatory, but nearby. They were smelling smoke coming from the seams of the wall. The flight attendant discharged a fire extinguisher, but smoke began building in the rear cabin. There was miscommunication. The captain believed the lavatory trash container's fire had been fully extinguished and was of no concern. This was before they had no smoking, so little trash container fires weren't that uncommon. Then the captain began to experience what he believed was a loss of electrical power, including loss of stabilizer trim control. Smoke began building to toxic levels as finally the captain realized, okay, he needs to make an emergency landing. 90 seconds after landing and deploying an emergency slide, the interior was completely engulfed in flames and killed all remaining passengers on board. 23 passengers died. The aircraft was completely destroyed. The NTSB said that the fire was of unknown origin. They thought the flight crew misunderstood the severity of the situation and misleading information was given to the captain. The time taken to decide to descend was also a contributing factor. Following the incident, regulations were changed to make aircraft safe. So after this, they required smoke detectors in aircraft lavatories, floor-level emergency lighting, and firefighting training and equipment were improved, and procedures were put in place so that all passengers seated by overwing exits were briefed on the operation of exit doors. So a lot of regulations came into place because of this.
Audio detection in the bathroom, that's only for Part 121 operations.
Right, that's not every single aircraft, but ones that carry a certain number of people are under certain regulations. Yeah. Fire triangle. Someone tell me what 3 things we need to make a fire. Kiki, give me 1.
Air.
Joe.
Fuel.
Fuel.
And a spark.
And a spark. Excellent. Oxygen supports and sustains the fire. Fuel is any material capable of burning. Heat is ignition and accelerates oxygen that is combining with the fuel, and there's your cute little triangle to help you remember it. This accident was in Moscow in 22 or 23. They were airborne briefly before returning to make an emergency landing. Still heavy with unburned fuel, the jet ignited after a rough touchdown. Because he landed so hard, the pilot was charged with negligence. Very interesting.
Wait, the fire started after?
Yeah, so the fire started, he realized, returned for emergency landing, but instead of doing a nice normal landing, he crashed into it. And it was realized, I don't know if he was, who knows.
So the initial emergency wasn't even a fire?
It was, yes.
Oh, okay.
Yep. But yeah, he could have landed nicely and not injured people like he landed.
Hey, look, as a foreknowners to any potential passengers with me, if our airplane's on fire, there's a good chance it's going to be a rough landing.
But can you be as smooth as possible?
of fires in an airplane.
Static electricity on the ground.
Good, yes. Yep.
Some sort of cargo that maybe flammable.
Yes, excellent.
Or aerosol.
Know what cargo is being loaded into your aircraft. Know if it's flammable or not. What are some other things?
Overheating tires or something?
Yeah, brakes overheating.
Pilot cigar.
Yes!
It's not
Literally, I'm
allowed.
here. I have people. People can do dumb stuff sometimes. So, watch your passengers. What are some other things? Some things that we mentioned, but that might not be right at your engine.
Reverse the electrical components.
So yeah, any electrical component anywhere, if you get a wire frying. So you kind of talked about these, but if you have a broken or loose fuel line, even coming down from your fuel tank, oil leak, cracked exhaust pipe, ooh, we'll talk about those, especially in turbochargers class. Cargo fires, post-crash fires, if you crash, have impact and fuel leaks, catches on hot, poof. And people can do unexpected things.
The people who do stupid stuff, do they typically get fired?
Make sure I'm not taking a drink next time.
Probably worse than that.
Oh my
Maybe get
goodness.
burned.
Oh my goodness. Moving on. That's not good stuff. So, what you also need to know is that aircraft, or, yeah, they are going to be divided into fire zones. This is not the question on your quiz yet. We're going to get to that. Could be a little confusing. So a fire zone is an area of the aircraft based on fire detection, protection system, engine airflow, and crew access. So they're going to take the whole aircraft, divide it up, and be like, does this area need fire detection? All right. Does it need fire protection? Is this airframe part, is this an engine part, or is this a cargo part? So initially they divided up into aircraft fire zones, and then power plant fire zones, and cargo compartment fire zones. So those are kind of our three categories that will have their own fire zones. This is the one you need to write down in your fire protection quiz. It should say, name 5 typical zones in aircraft that have fixed fire detection and or fire extinguisher systems. If somebody doesn't get this question, I'll be very sad. Yeah.
Does it matter which 5?
No, it does not. Pick your 5 favorite. So, what a fire zone, an aircraft fire zone is, it's on multi-engine and some other criteria that you don't need to know, that requires a fixed fire detection or extinguishing system. So this is curious because on the whole aircraft, the engines are included even though they have their exactly. You might not be able to get there with an extinguisher. Also, you might not see it, smell it, or know it's a fire until too late because you can't see it. So basically areas that aren't easily accessible, you can't see easily, need their own detection system. Anyone not get 5 Ds written down? Going, Panda.
Will these detectors send signals up to the cockpit?
Correct.
Okay.
Yes, and we'll talk all about that. But yes, there's a detection system in the area with wires up to the cockpit that gives an alarm or a light or annunciator or something. Yeah. Thank you for asking that. So that is aircraft fire zones. Now we hone in to power plant fire zones. Don't get too caught up in that diagram. I just wanted to show that on an engine, they'll split it up somehow. Every manufacturer is going to do it a little bit different. There's not one set way of how they do it. Just know that they do it, and you would go to the manual, see how a specific manufacturer would do it. What you need to know, I don't have it written up there, but listen carefully, is that power plant compartment fire zones are classified based on airflow through them. So airflow, the amount of airflow through a compartment determines what class fire zone it is. So you do not have to memorize these at all. These are just examples. Class A, heavy airflow with similar shapes. So maybe the front of the engine, yeah, there we go. B, heavy airflow, aerodynamic shapes, how they determine the difference between aerodynamic and similar. I don't know. That's the manufacturer. Class C, that's more obvious, low airflow. Maybe an accessory compartment or something. C, little to no airflow. So if you have the twin engine, they're out in the wings, up in the wing compartments or landing gear, wheel, well. X is very heavy airflow with unusual construction, so you got some weird stuff going on the top. So the manufacturer will say which one of those is where on their engine. Just know that it's based on airflow. Then we have cargo compartment classification zones. And if you're curious, you can research this in part 121. Is what tells large cargo aircraft that they need zones. And this is based on basically how easy it is to get to. So, and again, these are examples. You don't need to memorize these. Class A, fire easily discovered by crew member and accessible. So they can see it, they can smell it, they can put it out. Class B needs a smoke or fire detector, because maybe somebody's not in the area all the time. But if they get a detection alarm, they can run back there with a hand extinguisher. Class C needs a detector and an extinguisher, because maybe that's down here where they don't have access unless they become a wing walker or something. Class E, unique to cargo only and not a passenger cargo airplane. And it needs a smoke and fire detector, but it is unique. It might not need an extinguisher because they may have airflow shut off to that compartment. So you can just boom, shut off airflow, and then there goes your oxygen, fire goes out. Obviously, can't have that for passengers.
Just hold your breath, gotta put fire
The
out.
pellets also go out.
Would it not take a long time to burn up all the oxygen?
Right. It would depend how big it is, like they would calculate that off. Yep. And it may have the airflow shut off and an extinguisher. It's possible.
Cover this passengers in foam.
No.
All right, guys, hold your breath.
So here is an example think is the primary purpose of a fire detection system?
Safety.
That's really good. Not quite what I'm looking for.
Is it a matter of making sure the aircraft makes it to a safe landing in a certain period of time, or?
Oh, he's good thinking. A little simpler. Close. Who should know that there's a fire?
Pilot.
Yeah.
Notify pilots?
Yes. So here you go. They're gonna ask you this so many times. Make sure you have this well memorized. The primary purpose of a fire detection system is to warn flight crew members that there is a fire, and then they can decide do I extinguish it, what's going to happen. Primary purpose to warn flight crew members. Now, there are 3 methods used to warn crew members. Does anyone have any idea what those could be?
Visual?
Good.
Auditory?
Excellent.
Sensing? Remote sensing?
Smell.
That would be awesome.
For everybody.
So don't overthink it. If you got audio as one,
Sensory, like is it buzz or?
visual as a separate one, what do you think they'll do next?
Audio visual.
Audio, visual together. Yeah. So visual, that'll be a warning light, bright light or a blinking light. Observation falls under that.
It was just appearing. This is gonna happen. She's like, I did that.
So, yeah, warning light or Whereas a fire, boom, all of a sudden, you have a sudden, massive increase in heat. So these are able to differentiate that. They are not alarming at a certain temperature only if they detect rapid rise of temperature. Yeah.
So when that rapid rise of temperature has steadied out, does it go off?
I'm going to talk about that. We'll talk about how they're designed and how they detect. And then flame detectors actually look at the specific light the flame is giving off, and I can detect if that is like light from a flame. We will talk about that more when we get to flame detectors, but it can detect like infrared or ultraviolet light switches. Have you talked about thermal switches in any other class yet?
Yes.
Alright, kind of, sort of. You feel you have a firm grasp, very excellent knowledge of it. You can explain it in depth to an examiner. Good. Whew. Because if you did, then I would feel very useless right now. How about thermocouples? You probably talked about those a bit more in depth, methinks. Alright, hold your explanation because I'm going to ask for it when you get to that. Then, we're going to talk about continuous loop systems. There are two of those, a Fenway and a kitty, not kitty meow, a kitty. And then pressure type sensor responder systems. And there are two types of those, single point and continuous loop. But we're going to talk about each one of those in detail. So, the thermal switch is first. And it can get confusing because there is a company named Fenway, which is a very popular company among aircraft manufacturers to use their systems. They make thermal switches, which are older. They also make continuous loop systems. So when you see the word Fenway, make sure you look to see if they're talking about the continuous loop or the spot detectors, which they call spot detectors. The thermal switch is what they call spot detectors. So if you see spot detector Fenway, talking about thermal switch, you see continuous loop, it may be Fenway as well. These operate on the principle of differential expansion of dissimilar metals. So, at a certain temperature, so it's a set temperature, the thermal switch inside closes, ka-twink, which completes the circuit to the indicator lights and alarm. Here is something that I believe is on your listening guide. The switches are wired in parallel with each other and in series with the lights and the alarm. Here's something else. You need at least one thermal switch. When we talk about other systems, two or more components will be required. For a thermal switch, you only need one. And you need a way to test it. Okay. I'll talk about this diagram, and then I have another cool diagram on the next one. So basically, there is a cylinder in here that is a different metal than these guys. So when it starts to heat up, and there's a fire out here, what happens when metal gets hot? It expands. This expands quicker than these. So what happens when the cylinder outside of here stretches
It
this way?
pulls the glue closer together.
Yep. So these, they look like kind of straps of metal. They're like this. Oh, nice and cool. And then when the cylinder outside of them, that the ends are attached to stretches, they go until they cool, and then they stop indicating. So that's a very simple explanation, and it is a simple system, just differential or different metals. This stretches faster than these, pulls these together. So the one side is connected to power, aircraft power, and the other side is connected to ground. So normally these switches are open until they heat up, and then they go complete the circuit to the alarm. Actually, I did that backwards. To the alarm. There you go. And then there is a test switch that will then also you see, using your electrical circuit knowledge, is there something that this test circuit misses?
Misses the switch.
Correct. So it's only testing the wiring, which is good to test. It is not testing the actual switch itself. So just be aware of that. And that's why they have newer, better stuff. These are on older aircraft, older systems, but it's only testing the wiring. Now, these guys are hardly ever go back because they're so mechanical, and that's probably why they didn't design a system to test the actual switch. The wiring for sure can go bad, corrosion, whatever can get in there. But yes, only test the wiring, not the actual thermal switch. Then they came up with wiring two parallel circuits together instead of just one single circuit. And that is so that a short can exist in either circuit without causing a false fire warning. So it needs both of these to activate to cause a fire warning. If you have more in-depth questions on how and why, you can see me after class. Case went over all the possibilities with me. Ooh, this is electrical wiring. Oh, this is beyond my abilities. But we figured that out. So if you have more questions, ask me later. But what you need to know is the reason they do two parallel circuits is so that a short can exist in either circuit without causing a false alarm. I will pass around some little thermal switches. So this is what they look like, all in their happy little casing. This one, you can come up here later and look at the guts of it, which is pretty cool to see. And you'll see the little hand. This guy here is an example of this parallel wiring circuit. I'll start that on this side. And I have one more. You can be thoroughly distracted. This is a board of thermal switches. And on the back, I put a picture of what we figured out with the closest diagram to it. Here you go. Here, Christina. But I'll actually do this real quick. So there are. What do you think you could do? Actually, let me go to this one. So here are struts, they call it here, are apart because our cylinder hasn't expanded. Here the cylinder expands, brings the struts together. This is a cutaway view of it. If you happen to have, now obviously this would not be an aircraft, happen to have a cutaway like this, what do you think you could do to test it? Obviously you could put a flame to it. What should I?
Push it up.
Yeah, so I can just push these little hands together. And the board.
That sounds like
What could I do? Down here I have some very nice thermal switches. I do not want to cut them apart. What could I do you think? If this one is going to power and this one is going out to ground, what could I do to test it?
make it hot.
Switch passed around, I think it has a temperature on them. Whoa, that one's fancy. That had to go back to manufacturer, I believe. But you'd order whatever temperature you need. Any other questions? Okay. Now, we are going to talk about thermocouples. Can someone give me a simple or not very lengthy definition of how a thermocouple works? Keith.
It measures different resistance based on the heat. Or is that the two?
Someone else. What is happening if I apply heat to this thermocouple? You're on the right track. Yeah.
Decent, you wanna go? Go ahead. So there are two different types of metal.
Yes.
And, as one is more thermally conductive, and as there's a differential of temperatures between one and the other, there's also a voltage potential drops. So you measure it with voltmeter.
Perfect.
But I think what Teague was talking about was a thermistor, which you measure with the voltmeter.
That makes sense.
Thermistor.
But yes. So these are two. Oh, here you go. Again, two dissimilar metals. The most typical is going to be chromal and constantan. And because they are different, as they heat up, they have different electrical. How did you say it? You said it really well.
I forget now.
Voltage potential.
Like they're different thermal conductivity.
Yes. So these little electron dudes are going, woo, and these little electron dudes are going, doo, 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 doo. And that difference sets up the differential voltage. Now they're all buzzing around there, and that makes a slight voltage, very teeny tiny, of 4 milliamperes of that. Very tiny, but teeny tiny voltage. So it generates a small electrical current with a rapid rise in heat. So if these guys are heating up at the same, yeah. But if there's a differential or rapid rise in heat, they will alarm. The unique thing about these, they do not require an external power source for the thermocouple to work in and of itself. Now, you're going to need that to make your alarm have power, but they'll ask you, does the thermocouple need an external power source? And you will say, no, it does not. So the way these systems work, you can have however many thermocouple detectors that you need. So if you want to cover a large area, many do you need? You always need, how many do you think? Yeah.
2.
At least 2. So you can have one all protected in a reference junction that's protected from fires. He stays cool. And then one wherever you want to detect your fire. So then one can be like, I'm hot. And the other one says, I'm cold. And then you go, ah! Like that. And then you might have a separate one to test. And you would test that one by applying heat just to that one. So you have a test switch, goes to a heater, turns it on, heats it up. Now you have a differential between this guy and your reference junction. What happens is these guys are freaking out because they've got differences in heat. So that sets up that running around the little electrons and get little voltage. So here we have a very sensitive relay. You must be gentle because it's fire sensitive. detect very teeny tiny voltages. And so if it detects a teeny tiny voltage, then ka-drink, that sensitive relay closes and connects us to aircraft power. And now that ka-chunk closes our slave relay, which completes the circuit to the alarm. So we have to have a sensitive relay to pick up on that teeny tiny voltage, which connects us to power, aircraft power, so it can set off the alarm. Questions on that? I have a video. We're going to only watch a part of it. Does anyone remember what the guy's name is that figured this out? I don't remember. Sorry. So Seebeck effect is what is going on, and let me look here so I can jump.
This is a so-called Peltier cell, and this here is a thermocouple. We'll explain the thermocouple and the Peltier modules, and for that we will have to know the so-called Seebeck effect and also the Peltier effect. After that we will see what use we could give to these configurations. So first thing first, the thermocouple. Inside this very tiny ball of metal there are two different types of alloys joined together. When I heat this up, they will create a voltage drop, as you can see here on my multimeter. This voltage drop is extremely low, in the range of 40 microvolts per each Celsius degree. But we can still use this. All we have to do is to add an amplifier and amplify the voltage to something that we could easily read. So we do that and then we can measure the temperature. So that's exactly what this device is doing. This is a K-type thermocouple, and this device here has an amplifier and a correlation between the voltage read and the temperature, and that's how we can measure that temperature. But the interesting thing is not the amplifier part and the temperature reading, but how just two simple wires merged together could create a voltage drop. Well, let me cut this thermocouple wire. Inside we have actually two wires. One is covered with some red stripes and the other one with some blue stripes. These are not copper wires. Actually, these are made of two different alloys. One is called chromo and the other one alumo, and that's what makes this process possible. So look, if I merge them in a loop and place my multimeter in series, well, there's nothing happening for now. But now I heat up one side of the loop. And there you go. As you can see, a current is now flowing through this loop of a few hundreds of milliamperes. But how is this possible? Because there is no current source in this circuit. So let's go deeper and understand the Seebeck effect. Okay, so imagine a wire made out of a metal, so this is a conductor. The fact that this material is a conductor, that means that it has these free electrons, which are able to move around under voltage potential difference. But at the same time we also know that these electrons have a thermal energy. Actually, that's what temperature is, electrons bouncing around. So at the temperature of absolute zero, these electrons are not moving. But the higher is the temperature, they start vibrating more and more, having more thermal energy. So now imagine, for example, this wire is at 20 degrees Celsius, and all the electrons inside are vibrating with the same energy. But now we heat one end of this wire. So that means the electrons on the left side will jiggle a little bit more because they have more thermal energy. So that will make the electrons to be, in some sort of speaking, more separated, because now they vibrate more. So on the left side we will have less electrons because they are further away one from each other, but on the other side the electrons are get pushed. So we will have slightly more electrons on the right side. So guys, do you see what this is? This simulates a voltage differential, because we have a deficit of electrons on the left side and more electrons on the right side, creating a certain positive potential on the left and a negative one on the right. Okay, so this point here will be the principle of the Seebeck effect. So let's go even deeper. At the same time, it's quite obvious that different metals will have a different amount of free electrons. and this will require different quantities of thermal energy to start vibrating more and more. So that's why we use two types of metal alloys for our experiment. So for example, heating one to 100 degrees might create a certain voltage difference. But then heating the other one at the same temperature, since the alloy is different, the Seebeck effect is not as pronounced, so the voltage difference will be different. So now we take these two wires and join them in a loop. So remember that the top wire will create a voltage drop that, let's say, is greater than the voltage drop on the bottom wire, and we show that with the bigger V plus and the V minus. So once again, obviously, the current flow in the top wire is greater than the current flow in the bottom wire, from left to right. To understand this better, let's give some values. The top wire is pushing, let's say, 20 units of electrons clockwise, and the bottom wire is pushing 10 units of electrons counterclockwise. So now if I sum up these current values, which are just electrons moving around, the top current value will win, because the value is higher. So we would have 20 plus negative 10, which is equal to 10 units of electrons flowing clockwise. So we will have a total net current value like this inside of the loop. So that's it, guys. That's how we create that current on our wires when we present a temperature difference between the two ends of the loop with two different alloys. So that was the Seebeck effect. The current value, as you can see, is very low.
So, the things you need to know is when there is differential on heat, creates a small voltage. We need the hot junction that we expect to get heated up after the fire. Cold reference junction, which has a safe little fireproof box. That causes, if we get this guy hot, this guy stays cold, causes sensitive relay closed, completes power to the aircraft. Slave relay closes, oh yeah, I did say that. Completes the circuit, boom, boom, to the other. And we will get visual or oral or whatever they have wired in warning. Questions on thermocouples. How many do we need in a system?
At least two.
At least two. If you have a hard time remembering that, remember it's a thermocouple, and couple means two. Yeah.
Thermocouples only work when you have temperature difference in the actual thermocouple, right?
So these can be wired differently. I'm going to show you in a minute that if you have temperature difference in a thermocouple itself, it can create a voltage. But if the whole thing is heating up the same, then you need another one that is wired in with it, like this here, this junction over here, getting a different temperature to have that set up that voltage.
Right, because from the video it looks like that if the whole thing would heat up the same rate, then you could get like zero reading.
Right.
No, see that.
Right, but that's because one side is hot, another side is cold.
Right.
If both sides are hot, then there's no electrical difference.
Right. So that's why we need this guy in a reference junction so he can stay cold. This thing
Oh,
gets.
you have a whole nother thermocouple.
Right, right.
Oh, that makes sense.
Yep.
Okay.
And I'll show you that other one in a minute. So are thermocouples based on a certain temperature alarm or a rate of temperature rise? Rate of temperature rise. So they depend on a rapid rise in temperature to get that differential, because if it just warms up slowly, the guy and the reference guy, they design it so like if it's an engine is heating up, this does heat up slowly with all of these guys. That's up to the manufacturer, designer, how they make that work. But if all of a sudden we have fire down here at this end, he'll not have the heat with the fire. Boom, shows a different way they can put the reference thermocouple. You can put it far away from the ones that are, you want to detect the fire. And then there will be a test switch that heats up one of the thermocouples, and then you are testing the whole system.
So when you have a whole lot of them around, I think it's the turbine inlet temperature, right, that has them
Yep.
around? You wouldn't have, you'd have the standard temperature one you're comparing all the others to, or does each one need something to compare it to?
So turbine inlet, Case talk about those?
A little bit, I mostly
Good. Yep.
gone over that because it applies, but.
Right, and we'll talk about that in turbine class,
Okay.
but you would still,
I mean, for a similar application where there's a bunch of them, but.
let me get that. Okay, what is it? So, it is a slightly, so this is a ring of thermocouple. From PT6, possibly, that you would find on an engine. And it's a slightly different principle when you're using them to measure temperature rather than set an alarm. But the same thing is still happening. There you're getting a little electrons running around. Oh, we're getting heated up. So, I'll pass this around. Yeah, these are not fire detection thermocouples. They're just to detect temperature. But you can see what they look like. And if I could get Grant, our videographer, to help me out in a minute. There we go. So, if you could just,
I think you actually want geese.
well, whoever you choose. Oh my goodness. A volunteer to come video. So I have, that. You might have, I don't get it from the video.
No, it works.
Nope,
Just
okay.
like
Perfect.
dripping.
This little thermocouple for fire detection. You'll still see ring of thermocouples like on PC6 for taking temperatures, but not so much for fire detection. What they do use, because it's much more accurate and versatile, is a continuous loop overheat detector. So we got a loop, you can connect as many of these together as you need. This is our loop system on here. And we have two main types. A thermistor type. Anyone tell me what is a thermistor or how do you say it? Or if you don't know, what do you think it might be?
Did you say what is a thermistor?
Yes.
A thermistor is a resistor that increases resistance with temperature increase.
Or you could say varies.
Varies.
Varies with temperature. But yes, because you got the word thermal kind of heat in there, and then the ister. So yes, the resistor that varies with temperature. I'm going to talk about how, when, and what. And there are two companies that make them, two main companies that aircraft use. Fenwal, which also makes the thermal switch, and Kitty. Anyone know if they've seen Kitty company products? Yes.
I see a lot of them myself in the Menards.
On what?
Smoke alarms,
Yes.
fire,
Yes.
carbon monoxide detectors,
Yup.
all shapes, sizes. I think they have batteries too.
Oh, this is a different one. They make fire extinguishers too.
They do make fire.
They do. Yep. So they make lots of things, but they also make thermistor type continuous loop detectors. So we'll talk about these, and then we'll talk about pneumatic pressure types. Under pneumatic, the three main companies are Limber, Sister-Donner, Meggitt. Make sure you are familiar with these three names, because they like to ask you, how does a Sister-Donner system work? And then you have to go, oh, that's right, it's a pneumatic pressure type. So they do ask you these company names rather than just being nice and saying, how does a pneumatic pressure type system work?
On the,
So,
is that on the written, I'm assuming?
yeah. Yup. So just be familiar with Lindbergh, Sister-Donner, Meggitt, three companies that make pneumatic pressure type. Yeah.
So if they ask you specifically explain the fin wall or explain the Limburg or something like that, they're not asking, explain to me exactly how this company makes it. They're more asking what's the thermistor system opposed to what's pneumatic.
Correct. Now, here's the trick, and we're going to talk about this. Pneumatic pressure types, these all work pretty much exact same. So, if they ask Meggitt or Lindbergh to describe pneumatic pressure type, we are going to talk about there is a significant difference between Fenwal and Kitty, how they do their thermistor type. So, you do need to know the difference between these two. These three are pretty much all the same pneumatic pressure. Thanks for asking that. So, our thermistor continuous loop, we're going to talk about Fenwal and how they do it first. We got some really fun terms that you do need to know, because they'll ask you, this is a good one they like to ask on orals, so if you have to write it down, memorize it, pound it into your head like I did when I was a student. We've got an Inconel tube. So that's just what this tube is made of. And it is packed with a eutectic salt. That's your word of the day. Just a special thermistor material. It can be a eutectic salt. I'm going to make one of you say that soon. It can also, that eutectic salt can be in the form of ceramic beads covered with the salt. So you may see ceramic beads, terminology covered with eutectic salt, or it can just be packed with that salt. So two varieties for fenwal. But the Inconel outer tube, so here you see the beads, here you see the loop just packed with the salt. I like that. They say salt compound. Two varieties. In the middle of a fenwal loop is a nickel wire running down the center that is the conductor. You can have as many lengths of these loops connected to each other to reach however far. If you're going around an engine, around a wheel well, you can connect as many of those loops in series to the control unit. So these loops, if you have more than one, are in series. And you can connect equal lengths or varying lengths. You can have one loop set to sound to alarm at a certain temperature. If you think this area will get a cooler fire, you can set that at another temperature, totally fine. So they can be equal or varying lengths, different temperatures. Now, here's the question of the day. So as temperature rises when we have a fire, I'll give you this clue. So the control unit is putting a little current through that center wire. And it doesn't show on this one, it'll show it on the next diagram. The outer Inconel tube is connected to ground. So if we get a fire, the circuit is completed through the eutectic salt, connecting outer tube ground to inner wire, and the magic control unit detects that connection, sounds the alarm. So, what do you think happens to resistance of the eutectic salt when this is heated up? Yep. Our resistance drops with the rise in temperature. Then current can flow, and that activates the alarm. So that is what you need to know about this system. One nickel wire receiving a small current from the control unit. Inconel tube connected to ground. Eutectic salts or beads between those. As it heats up, resistance drops into the alarm. Questions on that?
That's just the fenwal system.
Correct, that is just the fenwal. If you know that, it will be very easy to understand the kitty system. There's one significant and yet small difference. Here is a diagram. They'll ask you questions about, might not be this one, but a similar diagram. So here they connected several lengths of loops together, 3 lengths of loops together. There is a test switch which will test the wire through the center. And there's a bunch of magic that happens in the control unit to detect the current flow from the ground to the wire if we have a fire. And then the control unit sends signal to our fire warning. What do you think would happen? Oh, here we have the magic in the control unit, if you like that. let's say we get a break in our wire. Ka-chonk. Are we still going to get an alarm if we have a fire in our main wheel well? How many say yes? Ooh, how many say no? Wow, there's a whole bunch of you that did it.
What's the question?
So, if this is cut, somebody slipped with a sharp object, sliced the loop right there, trunk, it's severed. If we get a warning of fire here in our left main wheel well, will it still work? Now, how many say yes? How many still say no? Okay, it will still work. Because this portion, we still got ground here, and we still got salts here, and we still got our wire coming up on this side. Will, if we have fire right main wheel with that place, or nose wheel well, will we still get an alarm? We will. Same thing. We are still connected on this side, which is why the loop is incredible, because it's a literal loop. It will connect the whole way around, whoop, both ends. Now, if it's a bad day and we got two breaks, two cuts in our wire, ka-chunk, severed, if we have a fire in our left main wheel well, will we get an alarm? No, because now we're cut off on both sides. This has no connection to our controller, so we're a goner. We're dead. Questions? Ooh, one more question. Okay. If we have just that one sever in our system, and we hit our test switch, so now we're connected to here, and it's going to go, are we good, are we good, are we good, are we good, are we good? Will it test that it is good? No, it will not, because it's going to go, are we good, are we good, are we good, I don't know, like that. So, the super cool thing with continuous loop systems, unless you have a terrible, horrible, awful, no good, very bad day, and it's cut off here and cut off here, even if you have a sever somewhere in the system, it will still alarm with a fire, but if you go to test it, it will test bad. So if you test at the beginning of the day, test bad, okay, we need to replace it. If all of a sudden you have something go bad in the middle of the flight, a bad test, but we know it'll still detect a fire. So, excellent system for that reason. Questions on that? Okay. Let's talk quickly about Kitty. Here is a picture of the fan wall. Here is a picture of the kitty. Do you notice the difference? The kitty has two wires, because every, hopefully, kitty, meow, has two little ears. The word kitty has two D's, whatever helps you remember it. So, we've got two wires through the there we go, make the pen won't go away. Bye-bye. Two wires still through our eutectic salt, still Inconel tube. A little bit different because one of these inside wires goes to ground, one goes to power. So rather than outside the tube going to ground, one of the wires goes to ground with the salts separating in between. When it heats up, these two have current flow. So just that slight difference. Questions on Kitty?
That's the only difference, just the tube. The internal tube's the same, the salt's the same, everything else is the same.
There may be slight variety
Has Finwall and Kitty both been over that one?
Correct.
Don't do it, man.
Always knew you were a bully.
No, I just defend people from what?
Being the bigger bully. Okay, so the three types of
Yes.
That's so funny. I love that. Bro, I can kind of like how everyone's not all real because I
That's definitely less than 60.
I know. I'm like,
So
gotta add it.
so good.
Gotta add it.
Yeah. What are we debating? But no, 16. 16.
Yeah.
That looks weird. What you got? Illegal.
On airware.
What do you look talking about?
Just to go back to
But you'll see.
Pinterest has a lot of fun ideas.
You got 5 more in you.
Is that the soccer ball? The
You got
airframe
3 more in you.
ball?
Come on, Caleb.
I saw a video.
You got 1 more in you. You got 1 more. 1 more. Ah, it's 150 today. Dude, how many was that
Did
right
you
now?
make a little
30.
helicopter?
Let's go.
A little, like, a little.
Let's go.
remote
10 more
control
than
that
20.
Kind of worked in that.
Yeah.
Yeah, instead of.
Good. That's how it goes.
Instead of a blade, it had like spinning wheels inside. Awesome. Something like that.
It's all my fault. It's all my fault. It's always all your fault, Carmen. I'll give you some.
Oh no, you didn't grab a little soldering iron?
We didn't have one. That's only one we had. The Uno attack broke.
Oh no.
Couldn't get it to turn on. And this was with my family in Flushing. Uncle George says, "Well, if I take this little clip here and this little clip there and attach these two, you can see if they're connected, they work. But they got disconnected, so if we solder in between them, we'll never be able to shut the game off, but we can actually play."
Oh no.
So he goes, "I have the soldering iron at the garage." He's an automotive mechanic.
Oh my goodness.
So he gets out this big thing. And what in the world kind of soldering iron is that for the circuit board? This is going to be interesting. So we all sat, watched the solders.
How did he get it?
It worked. Didn't look half bad. But you really wanted that bigger area because you're taking 2 little areas across which they're not necessarily supposed to go across.
It's not like teeny tiny.
It was a little itty bitty
So it's set up with a VA.
So the only place is the bottom, and then once you got lower to the ground, it's rat. There's two. Kinda like a
Oh, back. Go to, question number one. Okay. That was, I believe that was 32. Thank you. I didn't even know I left it.
What the heck? Why?
well, like it. So it was called one second. Yeah. Two. My guy. Why do you wear your
I don't.
The mag got lower than a deck.
I wear my wedding ring, that's about it.
Yeah, we didn't actually just have a
Okay, whatever.
Yeah.
A little more
Are you married me? Golden hammer?
Yes. I don't.
I had too much fun. Alright. Wow, it's time for the beating stick. You're not sitting down yet.
Yo, you're in trouble. Yo, yeah.
Time to start. You're fired.
Hey,
Alright, so there was a question on the listening guide. Name 3 types of continuous live fire detection systems. What 3 things did you put down? Kitty, Fenwall,
And I picked another one.
and pneumatic. So for sure you need kitty. For sure you need Fenwall because even though those both operate with thermistor material, they're different from each other. And then your third one should be, you could put pneumatic, which covers this we were talking about, or you could pick one of the companies, Megit, Donner, and I forget the third one. Lindbergh. So, Fenwall, kitty, and pneumatic. Questions on that? Yes.
That picture there says ceramic core. Is that ceramic with that salt stuff, or?
Yep. It could be representing the ceramic beads that are covered with the tectic salt. But yeah, a thermistor material. So with kitty, the cool thing that they do is they can do a dual loop. So watch out when they talk to you about dual loops or versus parallel loops. not get a false fire warning. There was a system we talked about that they will do 2 parallel circuits. Yes, thermal switch. So thermal switches, and that one set that I was passing around had 2 sets of wires, so they can be wired in 2 circuits. That is different from, very different from a dual loop system. But the way, and we're gonna go through the prep work questions, the way they phrase it can be confusing, so just make sure you read questions thoroughly to decipher what they're talking about. So a dual loop also does reduce false warnings, and it would be just another loop coming out of our control unit, following the same path, coming back in, and they'd be running close together. This will not, just like Fenwall, it will not test with a broken element. Yeah, anything that'll reduce false fire warnings, and they're wired in parallel. There was a question on your listening guide to briefly describe the components and operating principle of a KITTI, continuous loop fire detection system. What do you think you would include in a brief description? If you give me paragraphs and paragraphs, I'm gonna be like, ugh.
2 wires.
What do you say?
2 wires.
Good. 2 wires.
2 wires to the center of a biconal tube.
Good.
Here's the ground and here's the.
Very good. And how does it work? Yeah.
This is the question.
Yeah.
Are they also wired in series then, considering the way
Correct.
there's
Yep. If you have several sets of these loops, yep, they'll, to make it as long as possible, you can keep, I have one here, like I could take this, connect another one to it, connect another one to it, that would be in series. If I have 2 separate loops, that would be a dual loop system.
Are those loops going, are you saying, what is the loop, is it going, is that the wires that are going through the incanal tube and they're being looped, right?
Good question. I think this is the best one. So, this is our loop. Inside, like this, you would look at it, you would see the incanal tube. Inside of that tube is the 2 wires. And then you can have a second loop to make it a dual loop.
So would you have 4 wires in there then?
Yeah.
Is that what you're saying?
There'd be
Okay.
2 in this one and then 2 in our second.
Okay.
And then I think Zachary asked about connecting in series. So if I wanted this to just not loop out and come back, if I wanted to go over into a wheel well, make sure I cover that area well, and come back, I can connect another loop to that, another to that, another to that, another to that, another, so I come back to make it as long as I need.
So you're saying the thermistors are connected in series on this?
The thermistor is just the material inside of the incanal tube.
What's connected in series then?
So, let me take this. So if I have, so this is a loop. The loop is referring to the whole thing. So this is my incanal tube that I'm touching. Inside of the incanal tube is the wires, the 2 wires. I'll pass this around, you can see that. Now there would be a connection on the end of these that got cut off. But I could take another loop.
Add it to that.
This is a pneumatic loop, but we'll pretend this is a KITTI for a minute. And I could connect that and then stretch this guy out wherever I want to detect. Connect another one, stretch that out. So I'd have like 1. Now, maybe it's confusing, I don't know. A loop doesn't mean it's doing this. Like I can stretch this out and now it's a straight, but it's still referred to as a loop because however many of these you connect, it will always come back eventually into the control unit. So you do have the whole thing looping around, coming back to the control unit. But one section doesn't have to do that. You can have many sections. Does that answer your question?
So you can only buy this stuff in, let's say, what is that, 4 foot, 3.5
I don't-
foot increments?
I don't
You
know
can't
how,
buy a
but-
size that you need. You have
It
to
depends.
connect them.
Yes. Yep.
Okay.
If you have a, now this is just a part of it. It would be longer than this. But yes, depending where it is, and I have not gone online to buy loops. But yes, they are ordered in certain lengths. Because if you want a short area, you don't want to have a 10-foot long loop. You have to coil up. And then it gives you other problems. Joe.
Is it just me, or is the subject making anyone else feel rather loopy?
Ta-da! Oh my goodness.
Stop.
So I'm gonna pass.
Randall, stop.
Oh yeah.
So,
Tom.
sorry, you're gonna say something?
No, go ahead.
So, okay, so my understanding is one of these wires is grounded.
Correct.
The other one is next to it, inside of this tube.
Correct.
And as it heats up, the resistance disappears.
Correct.
And it completes a circuit.
Correct.
And then that sends an alarm,
Yes.
a signal to stop the alarm.
Perfect.
Okay.
Perfect. Now I have a requirement. You're the advanced class. When I pass this around, you're gonna see too many outfitting wires peeking out. Please make sure there's still 2 little icky wires peeping out when I get it back. Because we had more length of wires peeping out last year. When I got it back, they were not there. So people are like, oh, look at the wire. Oh, look at the wires. So please be gentle with my kitty. Oh, I forgot to pass around. What are these guys? Thermocouple, so I'll pass these around. Oh, sorry. Okay. Any questions on kitty or Finn? Going. Gone. Now, we're gonna talk about the pneumatic. Under pneumatic, we are gonna talk about pneumatic continuous loop, but there's this little oddball guy, a pneumatic single point detector. So operates on the exact same principle as pneumatic loop. So we'll talk about this first and then carry the information into a loop. So this operates on gas laws. So go way back to physics at the beginning of the year. And there will be a sensing element that is a closed helium-filled tube. And that helium-filled closed tube is connected to a sensor responder assembly. When this gas in here is heated, because we have a fire out here, what is going to happen to the gas pressure?
It's gonna run, it's gonna build up.
Yes, pressure increases. Whoop, and guess what happens? This is increasing and it pushes this little alarm switch, which is normally open, over beep to power. Beep. And now we get an alarm. Oh, I thought I had a thing for the alarm. I don't. Okay. An alarm. So it's an internal switch that closes as this expands, comes over and touches it. Alarms in the cockpit. And when our fire goes away, because we extinguished it, now what happens to gas pressure when it cools down? It reduces. So there is an integrity switch, which is normally closed. So this guy goes out that way, and this guy comes in this way, and he is always holding hands with the integrity switch. But if we have a gas leak out there, and this guy falls back, ka-chunk, now we're not holding hands, and it alarms. Says, you have a problem, you have a gas leak. Questions on that? So pretty straightforward operation, and this would just be like a probe, just a single point if in one area where you're afraid to get a fire. Not very common at all, because we like loops. So we take it, and same principle with a pneumatic pressure switch. Notice what kind of lines are these? You got physics and drawings. Woohoo. Brake lines, so that means this might be very, 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 very long, like this loop here. The three companies that you do need to be familiar with, Lindbergh, Sister and Donner, Meggitt, all make pneumatic continuous loops. These are on transport type aircraft, more common. Other aircraft like Kitty and Benoit loops. Typically, they will have dual loops, so they'll run two loops that way. If one senses a fire, the other does not. They know either one is broken or else one is giving a false warning, so they can integrity check each other. There may be two sensing functions, so they can get fancy with these. And they'll have, for an average temperature, they'll have the helium gas inside the detector, there or there, and the pressure diaphragm that works just like we talked about the single point. We get hot, the helium expands, pushes us over to make our alarm go. But what if we have slightly lower temperature that's still a fire, that our helium gas isn't expanding yet? It may have a hydrogen-filled core. So this one shows that hydrogen-filled core that releases at a lower preset temperature and will still activate the pressure switch. So it just makes it a little bit more sensitive depending if you need it. Yeah.
So I would assume has to be replaced after the hydrogen release.
No, it will reabsorb back into the core.
this pneumatic pressure sensor. And if it gets too high, then it can send an alarm to the control unit.
Perfect. I like this diagram, it's kinda cool. And this has, oh, maybe another material inside, and what could it have four of? What gas? Could have hydrogen filled core. And as gas temperature goes up, what happens to pressure? Decrease. And I want you to talk about this diagram in your book on, who can be the first to find it? Go.
Found it.
Woohoo! 17-6. So it talks about, it calls this a loop detector system. I'm going to talk a little more about it in your lab. What? How can you tell, just looking at this without the words, that it's a single point, or it's a loop rather than a single point? Anything that's telling you that on there? Yeah.
There are 3 wires, one going to ground and 2 going to something else.
That wouldn't necessarily be a difference between single point and loop. Alright. You're as stumped as I am. So what should they have on here to indicate that this is a loop? They should have break lines. Now, they take this out and expand it, but they need to have break lines to show that this is a continuous loop. So if you want to make a note of that, and then there's some pictures in your lab you're going to have to identify, but I'm going to go over those to try to lessen your confusion. Alright. We've got 3 images up here. Which one is a pneumatic system?
One on the right.
How many agree? He's right. And what gave it away for you?
The helium gas.
Yup, it's labeled helium gas. Which one is kitty?
The middle one,
The middle one, and why?
2 wires.
It got 2 wires, and that leaves this one as bad. Just make sure you're familiar with differentiating those. Oh, and here I have, this one is labeled, I think, yep, cistern donor. That is a pneumatic loop. Okay. Does anyone, how many of you are not at all confused with all these different fire detectors? How many of you are like, bam, I got this down solid. I could test today. Alright, that's what I figured. Okay, so I did this.
Shapes.
I'm gonna try to categorize. I like shapes and I like colors. So if you don't like shapes and you don't like colors, sorry. Got to deal with it. Okay. And then, Shane already mentioned our two types of thermistor continuous loop. You got Fenwal and Kitty. And what's the main difference between those two?
One wire versus two wire.
And which one has two wires?
Kitty.
Kitty. And someone describe briefly the operating principle of continuous loop thermistor type. What, as heat comes up, what makes it alarm?
The resistant goes down.
Good. And what are two components that they both have that are weird words that you have to remember?
Iconal too.
Yep. Iconal tube.
You.
Yeah. Yeah. Oh, you Tectic salts. So thermistor salt core around the wire or wires. And we have a system that is a loop, but it's not thermistor, it's pneumatic, so then I made a little green guy. And we already talked about the pneumatic loop, and what happens as it heats up.
The gas expands.
Gas expands. And what is our one last pneumatic type that is not a loop? Single point. So there are the systems we talked about categorized. Yes.
Is the single point pneumatic style similar to these right here next to Corbin, where it's just like a little probe almost?
Yeah.
Typically a couple inches long?
Yeah, like it won't be super long.
Okay.
And again, very, very rare on aircraft. It would only be in ancient old stuff that you would find it.
Ancient also.
Ancient old stuff. That means it's older than ancient. And it's more ancient than old. Okay, time for Z cup. Da-dum. 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 All right. So I took prepware questions, but instead of making a multiple choice, I just have the question as though it was asked to you in oral style. So then you should only get the right answer. You're not looking at all these wrong options. Unless they have weird wrong options, and we do talk about those. So the first one up is random. Why does the Fenwal fire detection system use spot detectors wired parallel between two separate circuits?
But if you have a break, then it still works. Get one break.
And what if it's not a break? What if it's another certain type of fault? Okay.
A short will give you a false alarm.
Yes. So if you have a short in this circuit, it won't give a false alarm. What you said is true also, but they will ask you and give you this option. You can have a short and it still won't give a false alarm. Marcy. A thermocouple in a fire detection system causes the warning system to operate because of why? How does it work?
Basically, you've got two wires in it,
activated by hitting a certain set temperature. Either they're scared to raise a hand, but I don't think so. How many say it is activated by a rapid rate of temperature rise? And they're correct. Chitterquist. Oops, there's your answer. Okay. Now, cheddar. Oh, there we go. Okay. Now, when used in fire detection systems having a single indicator light, thermal switches are wired in how with each other and series or parallel with each other, series or parallel with the light.
I would think series with each other. Parallel?
This is a good one for a vote. Now see what they all think. So, how many say series with each other? How many say parallel with each other? They're right. How many say parallel with the light? How many say series with the light? There you go. There. Very good.
Just a question.
Yeah.
This little guy right here that Randall's got, is that a fan wall continuous loop?
That is, if you look on the little thingamajiggy on the end,
This is pneumatic.
it is pneumatic. Yep. Yep. It's so teeny tiny.
Really?
Yeah. Yeah, it is. Pretty cool.
Okay.
Pretty wild. Yep. All right. France. The thermal switches of a 5-metallic thermal switch type fire detection single loop system are heat sensitive units that complete circuits at certain temperatures. Isn't that lovely? They are connected. How?
I'm pretty sure this is like the last one, parallel with each other, series with the light.
Nailed it. Do they like to ask this question in a million different ways? Yes, they do. Will they ask you this question in a million different ways? Yes, they will. Will they throw a whole bunch of gibberish? Yes, they will. People have gotten thrown off by
Just having a look.
Looking and taking notes.
You do get credit for initiative.
My brother got credit too, but his actually counted towards a grade.
Awesome.
I don't think Smiley does that.
No.
Said,
FYI
well,
said no.
they like saying that, but it actually doesn't count for anything.
I know, we love saying it.
You get extra credit for it. Well, he actually did get extra credit for it and got over a 100 or whatever. There goes my 100.
I've gone down 0 weeks.
Now, Kitty, I don't know if Benoit can do all that
Rose.
he does. So, well, the one wire to green power.
Which one's cheaper?
I do not do it.
That's why we buy it there now.
Alright, for those of you that are back on time, you get to see the groups. These labs are to be done, well, practical labs, to be done in groups. So, you can see, can you see? I don't know. If I was in the back row, I could probably actually see. There is actually, for the back row, I did put a paper on the bulletin board. So, you can see that. And most of the labs are going to be rotating through in numerical order. That's the plan. You know what happens to plans. Plans from which we deviate. But this is what we will start with. So, when I talk about lab 1, and I talk about question 12 on lab 1, which is you come and identify all these little letters on the board. That is to be done in your group together. So that way I had planned 2 people here, and then today we're not going to get to other labs. But tomorrow we're going to be doing things with the smoke detector, cycle people through, and then that way I can have orderly flow into the next labs instead of random people coming up and I don't know who did what and who I have to say the board for. Try to keep it orderly in group. So if you already looked at the board, great, but you need to do it in group. Questions or concerns?